Welcome to CocoaHeads 168, or 168. Thanks for coming. It's good to be here. In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islanders peoples today. Ooh, tonight we have, I practiced as well, Marcelo Esperidiao. No, got it wrong? Okay. And then he's presenting on gRPC code generation pipelines. And Daniel Slone, a fan favorite, building data sources using result builders. So excited about that. Should I make the month that wasn't joke? I've just did. Yeah, I was doing it subtly. Okay, we have a code of conduct here at CocoaHeads. If you're being harassed, notice someone else is feeling uncomfortable or being harassed in a difficult situation, or have any other concerns, please get in touch with one of us. Or there is a website too down the bottom that you can submit. Is it anonymous? Yeah, it's anonymous. Yeah, cool, an anonymous form if that's how you choose. But yeah, just make sure people are okay. That's our job. Housekeeping. The lifts, no, the toilets. The toilets are past the elevators. Just go out there and turn right. And then the emergency exits are near the toilets. So if you see someone running in that direction, yeah.
Could be
one or two of those reasons. There's name badges or name tags. Mine's falling off. If you see someone with a blue dot, it means it's their first time or they're new, and they just make them feel welcome. And then, do we have the badges on? If you see someone with a little white CocoaHeads badge, or that looks like Rob, or myself, or Daniel, and others, we can help you out if you have any questions. So come up to us. Questions during the presentations, let's keep those presentations until afterwards, and unless the presenter specifically asks you during. And also feel free to post in Slack just because we want everyone online to feel included. We'll go around with microphones and ask questions on people's behalfs from on Slack. It helps the evening flow better and allows people to participate. There's stickers at the door. Please help yourself. We've still got plenty left, so put them on everything that is legally allowed. We'd like to thank our sponsors, gold sponsor EBD Apps. We wouldn't be able to do these nights without our sponsors, so we appreciate their support. Blue, our silver sponsor, thank you very much. It lets us put on these wonderful nights like Hack Night, which is next Wednesday the 16th. Bring your laptops. It's a shared event, so there's like people from Google and stuff like that are like GDG, and Flutter also attending. And it's been good fun lately. There is also the drinks night, which has moved to the Fad Gallery, I'm pretty sure. Yep, so venue's all right. We're enjoying it. Yep, that's good fun. That's on Tuesday, the 29th of August. And then what's making a comeback is CocoaHeads Breakfast. Now, I wasn't sure which emoji to pick, so I picked both of them, but we can discuss which one we want to keep later tonight. So that's going to be the first Monday of every month, and the next one, the first one coming back is going to be Monday the 4th of September. And then Amy's driving that a lot, yeah? She'll be there for sure? Yep. Awesome. It's at 7:30, that's right. 7:30 at Axel Coffee on Elizabeth Street. Other groups, there's Sydney CocoaHeads and GDG Melbourne. We do some collaborative stuff with those guys, and we support them like they support us. How to find us. You can go to the website, cocoaheads.com, and now there's some important Slack news, which Rob's excited to tell everyone about.
I'm not sure if excited is the right way, but when we tried to explain it to you...
I didn't get it.
So coming up in the next couple of days, maybe a bit longer, What are you doing?
I thought I was blocking you on the camera, but I realized it's just a shadow, so now I'm sitting here. Continue.
Okay. Coming up in the next few days, we will be renaming our Slack incidents. So it won't be CocoaHeads Melbourne anymore. It will now be CocoaHeads Australia and New Zealand. And we will be inviting the other groups to join in on that with us. Nothing will change as to how we use it. Same code of conduct. All of the same people will be there. We're just opening it up to more of the community because, to be honest, quite a lot of the people from other groups are already on our Slack instance. So it's just formalizing that a little bit. What was it?
No, that makes sense. Thanks, Rob. And we're also on Mastodon. Mastodon. Cool. This would have been the Slack thing. But yeah. Jump on the channels and stuff stay the same. You said that, right?
Some of them will get
merged in that.
Prefix, but otherwise
Okay, cool. We'll update those once we, go forward with it. But those are typically going to be the places. Tonight's event is going to be in the Melbourne meetup most likely, and then volunteers, jobs will be shared. I'm guessing. Yep. And then speakers as well. So we're always looking for people to talk. If you've got anything to talk about and share, you can jump on there. And there's mentoring and stuff available. So if you want to just, learn how to do it, there's people like Rob that can really inspire and get you going. Okay, now, good. We've got our first talk. Marcelo, thank you. That's right, yeah? Thank you, Marcelo.
Yeah, I'm good. Thanks all for coming. My name is Marcelo. I'm going to be talking today about the gRPC code generation pipelines, which is a system that we have built in ANZ recently. Let's get started. To begin with, I'd like to introduce you guys APIs. This is our APIs. And what is it? Well, it's the home of all of ANZX APIs. Yeah, it's 100% built in protobuf and gRPC. It is absolutely free of any JSON, which it being protobuf makes it backwards and forwards compatible. It being protobuf, it's also platform agnostic, which means that we don't pick favorites because even non-iOS developers can be happy, right? Gotta think about them sometimes. Also, I'm not gonna be digging too much into the whole concept of protobuf, but more on the code generation part. But if you do feel yourself compelled, go back and watch Box Unbreakable API Contracts with gRPC, which was presented a couple months ago here in CocoaHeads. One key thing about our APIs repository is that it's paired with tech-specific code generators. And what is that specifically? Which means that our APIs repository does not deal with any tech-specific components, but we delegate that to platform-specific, such as APIs Swift, which is a very original name. We have API Scotland is another example. We have APIs Go, and we have more, but just for briefness sake, I'll just keep to these. And the way that this whole thing works is that every time a new API has changed, which actually is done through a PR being merged in the APIs repository, we ship off a tag, and that tag enables code compilation for these specific platforms, which in their own instances, they get shipped as artifacts to their specific technologies or platforms, right? So API Swift ships to Apple platform, API Kotlin to Android, and maybe some Java backends that we might have, and APIs Go is mostly focused on backend integration. API Swift specifically is fully automated, and it generates everything in Swift code from our protobuf and gRPC APIs repository, right? It's fully in Swift, specifically for people that use Swift, us. It's Swifty. It's fast. The whole purpose of it is so that our Swift developers, our OS developers, don't need to worry so much about what happens from the point where protobuf is specified to the point where the code generation is happened, and they have to absorb to the libraries or to the APIs from the application. And the way we deal with things is that we generate XC frameworks out of our APIs. So on the grand scheme of things, what we do is we receive tags from our APIs, which signify that there was a change in one or two or more libraries in APIs. API Swift goes and builds those and delivers artifacts to our artifact registry. And that in turn gets observed in the ANZ Plus application through binary targets. So this presentation is going to be a study of what happens in between receiving a tag and generating an artifact. Okay, we're going to go step by step here. Well, first thing that we have to do is actually we have to generate something that we have to generate the Protoc plugin that actually generates the Swift files, right? The way protobuf works is that it has a compiler shipped with it. It's called Protoc, Proto-C, and it works with plugins. And there is a Swift protobuf plugin, and there is a gRPC Swift plugin. And those plugins, they are open source projects as well, and they get versions. So we have to make sure that we're building with a version that's compatible with the libraries that we have in the app. Okay, so the way we use these plugins is on the command line. We just, when we call Protoc, we just apply the path to the plugins themselves, right? And the version that we want to use of these plugins is the versions that API Swift was built with, because the code that we generate is also the code that we're going to be observing and processing. So the versions that we want to use are the versions that are specified in our package.swift file. So how do we do that? How do we generate plugins that we can use by ourselves as well? And the answer is quite cool. The answer is through build plugins. So every time there is a build, we have a build plugin that depends on the code generator, on the Protoc plugins, builds them on the right version according to the version that was added as a dependency, and copies that into somewhere that can be observed by API Swift specifically. In this case, it makes it generated available through a bundle within the app. So that in that way, now we have the Protoc plugins that we need to actually build the Swift and gRPC code. Next thing that we have to do is when we receive a tag from the API's repository, we have to figure out what to build, obviously. And it's not as simple as just pointing out to the changes and just building it. We have to know what exactly what we're building needs, right? So we actually need to build a dependency tree. Now, to navigate you through this, I'm going to give you some examples. They are not actual Protoc files that we have in our repository, but they give a representation of what we have. So, for example, suppose we have a repository that has a payments proto file, and this payments proto file is able to do a pay request. Is my mouse showing? My mouse doesn't show. Anyway, so in this specific proto file, we have one RPC that it sends a message called pay, and then in the pay request, it has a payment request and it has a payment response. But you see that the payment message here is not specified in this file, so it's specified somewhere else. In this case, it's specified inside the same package, which is the payment package that we can see here in the import. And we can see the import actually to the type where to the proto file where the payment is specified, which is this one. So we know that the payment has a dependency on the type proto that specified the payment message. Now the payments message, you're going to see that has an amount, which is an integer 64, which is not a good type to store an amount, as don't do this at home. And we also have an account that we use to specify which account we are going to make the transfer to. Now this account also is not specified here inside this message, inside this protobuf file. It's specified somewhere else, which is in the account/type.proto that we see imported there, which is this file here. So in this example that I'm walking you through, suppose that the tag got generated when the services.proto file got modified, in which case we're going to have find out, compare the current tag to the previous tag, find out that services.proto was modified, and we're going to have to find a dependency tree of the dependency, so we have all the information that we need to compile. Luckily for us, if you want to explore or navigate the dependency tree, protobuf makes something available that's called the descriptor set file. Yeah, and we can use the protoc for exposing that. And that actually is the same file that protoc uses to communicate with the plugin generation plugins, with the specific code generation plugins. And we can, with that, we can go through all our protobufs, and we can generate a descriptor set that let us know the exact contents of our proto structures. So in this case here, we have, say, the descriptor protobuf, the descriptor set file is actually a binary file that was serialized from a protobuf file. And if we deserialize it in JSON, and here we are using JSON again, if we deserialize it, we're going to see that it has all the metadata that we observed just previous slides on the protobuf files. Now, how do we observe to this data so we can actually navigate and build a dependency tree? Well, it happens that since the descriptor file is actually the mechanism that protoc has to communicate with the code generation tools, protoc also, any code generation tool, we also be able to absorb to this descriptor file and be able to understand it. And it happens that Swift is no different. Swift has a library. Swift protobuf has a library that's called Swift protobuf plugin library that we can use to open the destination file, and we can, from it, we can find all dependencies that each of the files have. And that's what we do. We open the descriptor file, we open the Swift protobuf library plugin, then we navigate through all the dependencies, and then we create a dependency tree, which is simply a graph of objects. And we call it the protographer. Thank you. From there, before we actually generate any Swift code, there's also one extra step that we have to take. That's called building the module map. And a module map is a link between the protobufs that we want to compile and the actual generated Swift code. We have to, it's a way that is a specific to Swift way that we can use to tell it that, for example, in our case here, a payment, when it comes from a payment package, is actually going to be called as a module payment in Swift. And these are the proto files that belong to that specific module. And the same for account. And with that, with the Swift protobuf plugins built, with the navigation tree, the dependency tree built, and with the Swift modules, mapped. We have everything to do to generate our Swift code from the protobufs. Yeah? So let's go step by step. So for our proto command, we're going to start by specifying that we want to use a Swift, the Swift outs, which means that we want to specify that we want to build Swift code in this command line. We want to specify which plugins that we want to use, which are the plugins that were just built. We want to specify the mappings that we just defined as well. And we want to specify the files that we want to build. And ta-da! We have Swift code generated for us. Thank you. So when we do the generation of the code, we end up with an equivalent like this. We have, in our instances here, in our situation, we have a services proto, a type proto, and a type proto from accounts that they have converted to equivalent Swift codes generated by the Protoc plugin, the Swift protobuf plugin, and by the Swift gRPC Swift plugin. They get their own files. And what we want to do next is that we want to wrap this up in a proper, we want to wrap this up in a proper Swift project that has a proper Swift structure. So we're going to do that in 2 steps. We're going to, firstly, we're going to repackage move the generated files around so that they have the proper module names, because Swift protobuf doesn't do that for us. And then we're going to generate, manually, we're going to generate a package.swift file. And with that, this is what we end up with. We end up with a fully self-contained project that has the generated code from Swift protobuf. And we end up with a package.swift, and you actually build that. And you can build that and generate a package library as if you would be generating any other package.swift file. Now, up to this point, it was beautiful. It was clean, it's package.swift, but it starts getting dirty from here. Because now, when we start generating XC frameworks, first thing that we're going to be doing is we're going to be generating an Xcode project. And yeah, we cannot live in Swift package manager land forever. We have to work with Xcode as well to generate archives, XC archives, which is going to be our next step. And with that, we are going to be depending on the Swift package manager, which in version 5.7, which is the version that we depend so far, it has a component that allows you to generate programmatically an Xcode project. And if you do generate an Xcode project, it will be generated like something like this, which is an Xcode project that contains, you can see that all the targets that we were building in the previous step, it contains the payment and the account, plus all the Swift protobuf and gRPC Swift dependencies, which is a significant tree, actually. With that, we make a choice to what XC frameworks we're going to create on next step. We can generate XC frameworks from any of those schemas that gets generated automatically here. And we choose, when we're building for a specific library, we choose to build only for the library in case. In which case here, it's going to be for the payments library. That's the one that had a change in the beginning. But when we build, we actually go one extra step, and that we don't actually archive the project only for, we don't archive only for an iOS, but we also archive it for an iOS simulator, for the Mac, and for a Mac Catalyst as well. And that is so we are future ready, and whatever tools we have in the future that uses any variants of the APIs that we use, we're ready for them. So we archive them all. And for sake of efficiency, we do them in parallel. Everything that I've talked through up to this point is run on CI. The developers have no touch on it while the libraries are generated. So on CI, what we do, So on CI, what we do is that we run 4 different jobs over a matrix. Each of them, each of them building its own XC archive, because XC archive if you ever archived any project in Xcode, you will know that is a very expensive operation. And when we call each of these platforms in CI, we call using Xcode build, of course. With the archive command, we specify which project we're archiving, we specify the scheme that we're archiving, which you will remember comes from one of the targets that we had before. You specify the destination, that's a directive from Xcode build that specifies what platform / architecture / vendor that's going to be building on. The Trinity, the configuration, and last, if we're going to be generating XC frameworks, we need to specify the build library for distribution and the skip install options. Cool. So we run that for all of our instances building for different platforms in parallel, and then after they're all built, we create our XC framework. We get the XC archives created, and we put them together in a single XC framework. And that is another Xcode build command, which is a newer command. So what we do is we go through each of the archives that we created. We point out which framework inside those archives that we want to include in the XC framework. And there will be one for iOS, one for the simulator, one for macOS, and one for Catalyst. And we specify the output file. Okay. The last step of this process is actually preparing for us to actually upload an artifact to be able to be observable from the end of that being the ANZ plus app. And to do that, first thing that we have to do is gotta get this XC framework that was created, and we gotta name it with a version name that makes sense. So what we do is we call it the framework name. We call it, we put a tag number because the tag that came from APIs actually represents the version that it was built from. And then we zip it. And that is our archive. In our case here, in the example we're walking through, it was payments dash, for example, 330.zip. Yep. So this is what we covered. We covered what happened from a definition of a change in an API from in the API's repository until the point where the artifact is generated and put into our artifacts registry, and then observed from our APIs, from our end, which is the NZ plus app. Okay. Now, just to give a perspective on how this runs and the magnitude of what happens is that, firstly, we have about 140 APIs, and that is sometimes the same API, but in different versions or in different parts of their life cycle. Some are in alpha, some are in beta, some are actually ready for production. If you sum them all, we got about 140. A lot of them are in actually active development. At a specific time, we have 40 APIs being consumed by the NZ Plus. And since the system was conceived, we have generated 450 artifacts in a cadence of around 5 to 10 per day. And with the latest interaction of the build, with all the gains that we were able to achieve, thanks for Pete for a lot of help in that scenario as well, we're able to build each artifact with about 10 minutes. One thing else that we do is before actually PR is merged into the API's repository, we're able to check if it actually builds. So everybody that's doing a PR in the API's repository gets checked by API Swift. And if API Swift cannot build, which goes all the way until the phase where we actually build the package.swift, then if that phase is not successful, then we reject the PR and the author has to fix it. We got 30 of those per day, more or less, and each of those take 2 minutes. One else thing that is important to get a number across is that we have about 70 iOS developers consuming our APIs, and the estimate of that is that they have an infinite level of happiness. Seriously, everything that we have done from the concept of the API until the artifact arriving and the consumption, that's done automated. And a lot of our developers know exactly what's going on, and they are able to actually generate it themselves if they would like to, but they don't need to. And that just makes everybody's life so easy. And that's what I had for you guys today. Did anybody have any questions?
Not a question, but just a statement to sum up the impact of what this actually does. It means that within 10 minutes of the type-safe APIs being approved and merged in the PR repo, they're available for iOS developers to consume in the app and build type-safe SDKs and API calls against. And that's been a massive journey, like months and months and months of effort for Marcelo. So yeah, well done.
Thank you.
Question back here somewhere? No?
So once the so how are they consumed? You know, do you have to put them in the project manually? When you're ready to consume?
Well, they are binary targets, right?
Okay.
Maybe the way you consume binary targets, you specify the URL and you specify a checksum for it.
Okay. Cool.
So yeah, we kind of put some helper functions in the middle to make it simple to just specify the name and then the version and then the checksum, which people can get from the artifact registry. But it's as simple as that.
I wanted to start with a thank you for the talk, but I guess came back. Sorry, one more thing. Sorry. So even the packages could have been consumed, right?
Yep.
Is the reason you guys went for using the XC framework and doing all that?
Yep.
Publishing package could have been one way to do it.
Well, I think it goes down to two things really. One is version management, because we want to wrap up different versions of APIs in different binaries, and the other one is Swift doesn't really have at this point a way of us to keeping like separate projects with different versions, within project.
Yeah.
So if we had a project within a project and 40 of those within the project itself, that would have been a management by itself. So we wanted to simplify that by wrapping it in binary, XC frameworks, and just calling the right thing at the right time.
Thank you.
Sounds good?
Any other questions?
Sorry, how is the archiving here different from Xcode archive?
Xcode archive. Oh, it's actually the same process, but we do it automated instead of going through ID.
All right.
Actually, there's one different though. Just to clarify, in order for you to create an XC framework, you have to specify that it's non-installable and it's buildable for distribution. There are some parameters that I have to specify, but apart from that, it's just an archival. The only thing that you have to keep in mind is that once you specify those, you have to make sure that whatever you are archiving is API stable, which means that it complicates with some libraries really, because for you to guarantee API stability, you have to make sure that future versions of the app will be compatible with future versions of a library will be compatible with your library. So you got to make sure that sometimes with like inlineable operations that can break API stability. So you got to look after that. But apart from that, that's just an archival.
Thank you.
I've got a quick one. What do you see as, like, what's there to do for you now? Like, you've told us where it's at, but where's it going?
It's a good question. We're dealing with artifacts directly, right? It'd be great if we could do better at dependencies and versioning dependencies, as in if payment depends on account, we specifically specify that we need the account XC framework and the payment XC framework. It would be great if we didn't need to. So next step would be to investigate how better to find dependency and automate that.
Anything else? I think we're good. Thank you, Marcelo.
Thank you.
You got me in there. Awesome. Thanks, all. Hey, I am Daniel Slone, and tonight I'll be talking about building data sources with result builders. And so tonight, this talk kind of came out of me working a lot with data sources and collection views over the course of the last few months, and in my spare time, just exploring ways of using result builders. And I just wanted to see how maybe I could put those two together. And so tonight, I'm just going to walk through like a bit of a background to result builders and then show maybe more like a practical example, like a very simplified practical example. So why do we need data sources? Well, just as I mentioned, table and collection views, list, etc. There's a lot of different uses for data sources, really. And often we find that the data source may have inadequate data. So the client needs to fill in the gaps, combining multiple sources for this data. And we need to look at ways to combine it. And I think this is where a result builder kind of comes in. And so what is a result builder? Well, result builder is essentially allows you to create custom syntax in the code, otherwise known as domain-specific logic or language or DSL. And just a show of hands, who has actually used a result builder? Few. And what about SwiftUI? About the same people. Well, SwiftUI is essentially just a result builder underneath the hood. So let's create a simplified version of the radio tab in Apple Music. And if we look, we have a bunch of sections and a bunch of different data, likely could come from different sources, could come from other resources, and we're going to look at how we can maybe put this together with result builder. And this is maybe like a collection view or a list, I'm not really for sure, one of the two. And I'm going to combine the button at the top for the subscriber as well into this to make it fun, and also to add more data, and also the profile into this. And so what would an end result look like? Well, at the end, we might get something that looks like this. We have our radio tab as the parent, and within inside that, we might have our different sections with different data that we are passing in as an initializer, and all neatly packed together within the build call at the bottom. But before we get started, let's look at how we can create what I'm calling a content builder for our result builder. So let's start with the protocol. So we want to have like a generic one so that we can use across other types of data sources. In this instance, I have associated type that can just be anything that returns back when you call the build function. And then over on the content builder side of things, we actually don't need everything there. By default, we probably do need build block at the top two at this in content builder, and the rest are essentially optional based on if we need it or not. And so if we look, it's pretty straightforward. We just need to return like build blocks what at the top, just the component or components. And then build optional, well, that's also pretty easy as well. Just return back an empty array on that. And then with the build ethers, That's essentially just an if-else. I believe that can also be a switch case as well, if I'm not mistaken. And then the very bottom where my head's cutting off, it's build limited availabilities. Just checking if this is available. If you put like a if available iOS 16 and above, that will cover that there too. And so we can actually start looking at how we can use this with our parent or the radio one. With the content builder, we can pass it in as a initializer or function to create what we are wanting to build. And in this instance, I just have an array. I want an array of the content buildable protocols. I really don't care what's returning back. I'll deal with that in the build function in a moment. And then, so if you look at the initializers, we just do @content builder, and then just a builder, and it's just essentially just a closer, returning either an array or just an object. And now within the build function, I really just want a list type, an array of list types. So if you look at the bottom right, I've created something very simple for this example, just a list type with a button with associated type as a string. They actually have all associated types as a string or an array. And then I have a square card or carousel. Kind of match up with what we kind of saw at the start with the video. And within the build function, we just want to combine that together. So in this instance, I'm just checking if what I'm building is a list type or if it's a list type of an array. And then just packaging it up into an array and returning it. And so with these more smaller ones, like the subscription and the profile, they're actually really small. We want them really small functions here to make it very easy to test and less side effects. And so if we look at subscription, I'm just passing in it is subscribed and checking if it's not, I'll return a nil here. And if so, if it hasn't been subscribed, just return a button. Your data source is likely going to be probably bigger than what you want here, but I'm just returning a string for this. And then profile, you can have a user as your initializer and do whatever you like on the build. And so likewise, we're getting a bit more dealing with our data here with both live and broadcast. We are actually passing in an array of content that might be from a different data source. And if you look in the bottom middle, we have content with content type. It could be a live broadcast, podcast. And I'm just keeping a property of type and just a string. And with this, with both builds, I'm just filtering, checking to see if it's live or broadcast, and then just creating my list type to return back. And so at the end, you might get something that looks kind of basically, if we print it out, kind of basically what we would have at the start. And it makes a bit more sense to just kind of look at it, in my mind, kind of have more readability and context when you look at something in this matter. And as mentioned, it makes, if you have, with testing, it makes it, the smaller functions make it easier, and the logic is contained to the build function. All right, thank you. And I have included a couple links. If you look up awesome result builders on GitHub, you'll find some interesting ones like GraphQL result builder, HTML result builders, and then Apple Docs result builders. A lot of information there. Oh.
Any questions for Daniel? Anyone? Nothing?
No questions.
No questions. You blew them away.
Right, I know.
Like,
I hope.
Let's see. Can anyone dig one up? No. That's
No.
anyone got something? No, nothing? No. All good. Like
Thanks, everyone. There's some slides. Oh. All right. Well, thank you for Marcelo and Daniel for their presentations tonight. These are our other events this month. Hack Night, Wednesday the 16th of August. Drinks Night, the 29th of August. And making a comeback, CocoaHead Breakfast on the 4th of September, Monday. Thank you to our sponsors, Itty Bitty Apps and Baloo. And thank you all for coming. Now we're off to the Mitre Tavern. Mitre Tavern? Yeah, Mitre Tavern. All right, thanks, guys.